In section 2.2, we look at coordinate geometry, circle, and some other equations. Let's talk about how to find the distance between 2 points in a plane. Suppose we have a point x1, y1 and another point x2, y2, and those are just 2 points in the plane. And we want to find the straight line distance between those 2 points. What we can do is we can draw a horizontal line here and a vertical line here to form a right triangle. And in this right triangle, we know that we can use the Pythagorean theorem, right? So if we call this side B and this side A and this side C, we know that A squared plus B squared is equal to C squared. Now the question is, what is A, what is B? Well, A and B are simply vertical and horizontal distances. So if you look at A, for example, A is the distance between here and here. And that is a vertical distance which can be measured by subtracting the y-coordinate of the top point and the y-coordinate of the bottom point. So that's just y2 minus y1. We can find the distance here between these 2 points, which we called B, by doing the same thing, except now we are going to subtract the x-coordinates. So the x-coordinate on the right here is x2. The x-coordinate on the left is x1. And if I want the distance, I take the bigger number minus the smaller number. All right, so now if we plug those into this equation, A and B can be replaced with those expressions. We get y2 minus y1 squared plus x2 minus x1 squared is equal to c squared. Now keep in mind that c is the distance between the 2 points, so c is what we're actually trying to solve for. And so to solve for c, what I'm going to do is simply take the square root of both sides. Now the square root of c squared, if I bring that over to the left side, that's going to be c. And then the square root of the other side stays exactly how it is written here, except that I'm going to swap these. I'm going to put the x's first and the y's second. There's no issue with doing that. Since it is addition, it's the same thing no matter what order we add those in. And c is that distance, right? So c is the distance between the 2 points. So we come up with what we call the distance formula, which you can see right here. And it has been summarized quite nicely up here. Now what they do up here is they call that actual distance d instead of calling it c, okay? But it's the same formula. Next, let's talk about finding the midpoint of a line segment. So I have my same diagram here. I have 2 points, A and B. And this time I want to find the midpoint between the 2 points. So if I draw the straight line between point A and point B, I'm going to find the midpoint of that segment. This is what I'm looking for. I'm going to call this point M for midpoint. Now, the way it works is if you look at the x value of that midpoint, this point here will be exactly halfway in between x1 and x2. And if you look at the y-coordinate of that midpoint, that point will be exactly halfway in between y1 and y2. So how do you find the halfway point between two numbers? Well, the halfway point is nothing more than the average. So the coordinates are going to be given by an x-coordinate, which is the average between these two numbers. So that is x1 plus x2 divided by 2, and a y-coordinate, which is the average between these two numbers, and that's going to be y1 plus y2 divided by 2. Therefore, the coordinates of the midpoint is going to have an x-coordinate equal to this quantity and a y-coordinate equal to this quantity, and you can see those coordinates right here. So let's do an example. So in this first example, we are going to find the distance between the 2 points 3, -5, and 6, 1. So what I like to do is take each of those points and write one above the other. So I'll take the first point and write it down, and the second point, write it below it. We know our distance formula is the square root of x2 minus x1 squared plus y2 minus y1 squared. So x2 minus x1 means that we are subtracting the x values, and y2 minus y1 means that we're subtracting the y values, and we're doing those in the same order. So if I think of this as being x2 and I'm subtracting x1, then this becomes the square root of 3 minus 6 quantity squared plus, and now I'm going to subtract the y values in that same order. So that will be -5 minus 1 quantity squared. And now we just do the math on this. So we have the square root of -3 quantity squared plus -6 quantity squared. And this is the square root of 9 plus 36, or the square root of 45. And if you simplify that radical, you get 3 times the square root of 5. This is our exact distance between those 2 points. Now to find the midpoint between those same 2 points, we use the midpoint formula. And the midpoint formula is given by taking the x coordinates and finding the average of those two. So x1 plus x2 divided by 2. And then doing the same thing for the y coordinates. So for this particular problem, our midpoint will be given by, I'm just using the same points here. So x1 and x2 are these two numbers, so 3 and 6. So that's going to be 3 plus 6 divided by 2. And then the y coordinates are these two numbers, and so that will be -5 plus 1 divided by 2. And if we do the math on this, we get 9/2 and -2. So this is the midpoint between those 2 points. So now let's spend a little bit of time talking about circles. Suppose we have a circle graphed in the coordinate plane with a center at the origin, 0, 0, and the point xy represents any point on that circle. Now what I'd like to do is find the equation for all the points on the circle where r is the radius of the circle. So to do this, we simply use the distance formula. What we know is the distance between the point 0, 0 and the point xy is equal to the radius of the circle. So our distance formula says d equals square root of x2 minus x1 squared plus y2 minus y1 squared. And in this problem, the distance is the radius of the circle, which is r. And that is equal to the square root of the difference between the x coordinates. Well, one x coordinate is x, and the other x coordinate is 0, so that's x minus 0 squared. Plus, and then the same thing for the y coordinates. One y coordinate is y, and the other y coordinate is 0, so that's y minus 0 squared. And if we simplify here, we get r is equal to the square root of x minus 0 is x, and we're squaring that, so that's x squared, plus y minus 0 is y, and we're also squaring that. And then if we simply square both sides of the equation, the square here will cancel the radical, and if we flop sides here, we get x squared plus y squared is equal to r squared. So this is the equation of a circle with radius equal to r and center at the point 0, 0, the origin. So what we'd like to do next is find the equation of this circle And you'll notice that the difference between the two circles is that now the center of the circle is no longer at the origin. It's at some point that we're calling HK. So we approach it the same way. We're going to say the distance between these 2 points is the radius of the circle R, and that distance is equal to the square root of the difference of the x values squared plus the difference of the y values squared, and the x values are x and h. So we're going to put x minus h in the first set of parentheses, and the y values are y and k, and so we put in y minus k. And then just like we did with the last equation, we're going to square both sides of the equation, and when we flip sides, we'll have r squared on the right side, and on the left side, we're going to switch here and have this square root and square cancel out, and that's going to give us x minus h squared plus y minus k squared. And this is also the equation of a circle with radius equal to r, and now the center can be any point, hk, where h and k can be any 2 numbers, positive or negative or 0. Okay, let's take a look at an example. So here we have the results from the previous page summarized. The equation for a circle centered at the origin with radius r is x squared plus y squared equals r squared. And the equation of a circle with center at hk and radius r is the equation x minus h quantity squared plus y minus k quantity squared equals r squared. And now keep in mind that x and y in that equation are all the points on the circle. This is called the standard form of an equation of a circle. So in our next example, we want to write the standard form of the equation of the circle with a center at 3, negative 2, and a radius of 5. So I'm going to write down that information. Our center is 3, negative 2, and our radius, in this case, is 5. So keep in mind that your center of your circle is given by h and k. So in this particular problem, h is 3 and k is negative 2. And then your radius is 5. That's the quantity r. So now if we take those quantities and plug them into this equation, we're going to get x minus 3 squared plus y minus negative 2 squared is equal to 5 squared. And if we just clean this up a little bit, we get x minus 3 squared plus y plus 2 squared equals 25. And so this equation is the equation that represents all the points on the circle that has a center at 3, negative 2, and a radius of 5. And now we want to sketch the circle. So we want to sketch a graph to show what this would actually look like. So we have a circle whose center, remember, was at 3, negative 2. So let's first graph that point. 3, negative 2 is right here. I'm going to label that C for the center. And now to get the circle, we're going to use the fact that the radius is 5. So that means that all points on the circle are exactly 5 units away from this center. So from this center, I'm going to count 5 units to the right, 5 units to the left, 5 units up, and 5 units down. And those 4 points give me a template to graph our circle. And anytime you graph something like this freehand, it's not going to come out looking perfect. But what we want to make sure is that we have the center graphed perfectly and these 4 points graphed perfectly. And then we just do our best to sketch that circle. So in the next example, it's a slight twist. It says we want to write the standard form of the equation of a circle that has a center at the point -1, 2, and it contains the point 1, 5. All right. So let's remember that the equation for a circle is this. Now, what do we know for our problem? We know the center is at -1, 2. So that means that h is -1 and k is +2. And then we don't know the radius. So that's the problem here. But we do know that this point is on the circle. So when we say that the point 1, 5 is on the circle, or the circle contains that point, what we're saying is that 1 is an x value and 5 is a y value, and those x and y values must satisfy that equation. So if I plug in 1 for x, we get 1 minus, and then h over here is -1, plus y is 5, so we have 5 minus, and then k is 2, and that's equal to r squared. And this is going to allow us to solve for r. So what we have here is 2 squared plus 3 squared equals r squared. This is 4 plus 9 equals r squared, so r squared is 13. Now, that means that the radius of the circle is the square root of 13. But if I want the equation of the circle, I'm just going to come back up to this equation, and I'm going to notice that r squared is 13. So I can simply replace r squared with 13, and I can also replace h and k with -1 and +2, respectively. And that's going to give us x minus -1 squared plus y minus 2 squared equals 13. And then the only thing we need to do here is just clean this up. That's going to give us x plus 1 squared plus y minus 2 squared equals 13. And one thing I want to point out, in case you haven't noticed already, is that for the coordinates of the center, you'll notice that whatever the coordinates are here, in the equation, those numbers are always the opposite of what you see in the coordinates. And that's because in the equation, we are subtracting h and subtracting k. So that takes the opposite of those numbers. Now we also want to sketch the circle here. So let's go ahead and bring in a graph. And now we'll graph the center of the circle, which was at x equals -1, y equals +2. And from there, we have to use the radius to get the 4 points. Now, the radius was the square root of 13. So we need to figure out what is the square root of 13. Well, the square root of 9 is 3. The square root of 16 is 4. So I know this is going to be 3 point something. But let's go ahead and plug that into a calculator to get a better approximation. And when you do that, you get approximately 3.6. And now when I graph my circle, I'm going down to my center here. And from that center, I'm going to go 3.6 units to the right, which is right about there. 3.6 units to the left. 3.6 units up, and 3.6 units down. And that's as good as this one's going to get, because it's kind of hard to graph decimals perfectly, but this is a reasonable picture. Now, I guess I probably should point out that, remember in the beginning, they told us that the point 1, 5 is supposed to be on this circle. And I want you to look at 1, 5. So x equals 1 is right here, and y equals 5 is right there. So my graph is not perfect, but that point 1, 5 is supposed to be on that circle. So I would say we did a pretty good job of graphing that. But again, anytime you freehand graph something, it's not going to be 100% perfect. So now let's talk about the general form of a circle. So we already know that this equation here is the standard form of a circle. If you use multiplication to multiply out these parentheses, you will get this expression. And then reordering some terms, regrouping some things, you will get x squared plus y squared minus 2h times x minus 2k times y, and then plus h squared plus k squared minus r squared. Now remember, h and k are just numbers. So if h is a number, negative 2 times h is a number. So what we're doing down here is we're going to call this number, negative 2h, we're going to call it d. We're going to give it a new name. And we're going to call negative 2k, we're going to call that number e. And this number here, h squared plus k squared minus r squared, is also just a number, and we're going to call that f. And when you do that, when you replace this number with d, this one with e, and this thing with f, you get a simplified version of the general form of a circle, and you can see that down below here. So basically, the general form of a circle is x squared plus y squared plus a number times x plus a number times y plus another number is equal to 0. Now, the general form of a circle is not particularly useful. So one of the main things that we'll be tasked with doing is when you have the general form of a circle, you'll want to actually be able to put it back into its standard form. So let's do an example of that. So here we have the general form of a circle, x squared plus y squared plus 8x minus 2y minus 8 equals 0. And we want to rewrite it in standard form. Because once it's in standard form, you can easily get the center and its radius. So what we're going to do is rewrite this equation, x squared plus y squared plus 8x minus 2y minus 8 equals 0. And I want you to think about how are we going to convert that into an equation that looks like this. Well, it would make sense that this first expression here has nothing but x's in it, and this second expression has nothing but y's in it. So the first thing I need to do if I'm going to rewrite this equation in this form is I need to gather together my x terms. I need to write them next to each other, and I need to gather together my y terms and write them next to each other. And then, of course, on the other side, we have equals r squared. Well, let's just go ahead and take this number negative 8 and let's add it over to the other side. So if we do those things, we will get x squared, and I'm going to bring this plus 8x over next to it. So plus 8x. I'm going to leave a little space there. And then we have plus y squared. And then we're going to bring that negative 2y next to the y squared. So that's negative 2y. Leave another little space. And then to get the 8 to the other side of the equation, we have to add 8 to both sides. So this is going to be equal to 8. So now what we need to do is we need to take this expression and we need to make it into a perfect square. So that means we need to complete the square, which we have talked about earlier. So to complete the square, remember the trick is you take the middle number, in this case that's 8, you take that number, you divide it by 2, and you square it, and that number is 16. So I am going to add 16 here, and if I add 16 to the left side of the equation, I have to add 16 to the right side. And then we need to complete the square on this one to get a perfect square here. And to do this, we take the middle number, which is negative 2, divided by 2. And we square that, and that is negative 1 squared, which is 1. So I'm going to add 1 here and add 1 to the other side. Now let's think about what we have. So here we have x squared plus 8x plus 16. If we factor that, we get x plus 4 times x plus 4 plus, and then here we have y squared minus 2y plus 1. Factoring that, we get y minus 1 times y minus 1. And on the other side, we have 25. And so now you can see we have x plus 4 to the second power plus y minus 1 to the second power equals 25. So the center of the circle, remember we have to get h and k from here, but this is the opposite of h, so h is negative 4, and this is the opposite of k, so k is positive 1. So the center is negative 4, positive 1, and the radius is 5 because this number, 25, remember that's r squared. So that means that r must be 5. And they also want us to sketch the circle. That's no problem once we have the center and the radius. Let's bring in a graph. And we're going to graph that center, which is negative 4, positive 1. And then from there, we're going to go 5 units to the right, 5 units to the left, 5 units up, and 5 units down. And then we will just sketch the graph of the circle the best we can. And there it is. Now the last couple of examples are going to be examples of sketching the graph of various equations. So what happens when you get an equation and you're asked to sketch its graph and you don't recognize the equation? Well, one thing you can do, if possible, is you can solve the equation for y. So in this case, I can add x squared to both sides. And if I do that, I get y is equal to x squared minus 3. And now if I want to get a graph of this, all I need to do is get some points. So I can randomly select some x and y, or x values, and then find the corresponding y values. And sometimes these x values work pretty well. In this case, they do actually work pretty well. So then you have to plug those into your equation here. So if x is 2, 2 squared is 4, and 4 take away 3 is 1. And if x is 1, 1 squared is 1, take away 3 is negative 2. If x is 0, 0 squared minus 3 is negative 3. And negative 1 squared is 1, minus 3 is negative 2. And negative 2 squared is 4, minus 3 is 1. So now that we have these points, we can simply plot them and see if we notice any kind of a pattern. So we have the point 2, 1, 1, negative 2, 0, negative 3, negative 1, negative 2, and negative 2, positive 1. And this does appear to have a parabolic pattern, right? It looks like a U-shaped type of graph. And you've probably done this kind of thing before, right? And so this is one way to sketch the graph of an equation. This is just kind of sketching it the old-fashioned way, where you get a bunch of points, you plot those points, and you look for some kind of a pattern. Now our last example is a little bit trickier. We have the equation y squared plus x is equal to 0. Now you can try to solve for y. If you do that, you will get y squared is equal to negative x, right? Because you have to subtract x from both sides. And then you have to take the square root of both sides. And you get y equals, or actually you get the absolute value of y equals, the square root of negative x. And the definition of an absolute value tells us that y would then have to be equal to plus or minus the square root of negative x. So really it's kind of like you have two equations here. You have y equals the positive square root of negative x, or you have y equals the negative square root of negative x. Now you know that in order to get a real number, you cannot take the square root of a negative. However, this is okay because if x is negative, then negative x will be positive. So one way to get some points here would be just to plug in some negative values for x, or you could even plug in x equals 0, right? If you plug in 0, you get the square root of 0, which is 0. And then I can plug in x equals -1, because what happens is I get the square root of -1, which is the square root of 1, which is 1. And then I could plug in -4 would be a good number to plug in. That's going to give us the square root of -4, which is the square root of 4, which is 2. Okay? Now let's do the same thing for the other equation. And I'll use the same numbers. So I'll let x equal 0, -1, and -4. Now the square root of 0 is 0, and -0 is 0. When you plug in -1, it could be a little tricky. You get negative square root of -1. So that's negative square root of +1. And the square root of +1 is 1, but we still have this negative out here, so we end up getting -1. And when you plug in -4, a similar kind of thing happens, and you get -2. So now I can bring in a graph, and we can sketch those points. So we have the point 0, 0. We have the point -1, +1, -4, +2. That's from this one. And then from this one, we have the point 0, 0 once again, -1, -1, and -4, -2. And you could notice that this is really just kind of a sideways parabola. In fact, that's exactly what it is. So this is one technique for graphing this particular example. Let me show you another technique. So rather than solve for y, what if we had just taken this equation and solved for x? So we could do this by subtracting y squared from both sides, and this would give us x equals -y squared. It's kind of a simpler equation, right? Because we don't have the plus or minus, we don't have the radical. But now when you go to find points on this graph, the easier way to do this now is you're not going to pick x values to find y values. You're going to plug in y values, and that's going to tell you what x is. So for example, if y is 0, then x is -0 squared, which is 0. If y is 1, right, x is going to be -1 squared. Well, that looks like this, -1 squared, which really means -1 times 1, which is -1. And if y is -1, then we get -1 squared, which is -1 times -1, which is, again, -1. And then if y equals 2, we get -2 squared, which is -2 times 2, which is -4. And if y is, that was +2. That was y equals +2. And then if y is -2, we get -2 squared, which is -2 times -2, which is, again, -4. So now if we take those points and bring in our graph, you will notice that we get the same thing. So we have the point -4, +2, -1, +1, 0, 0, -1, -1, and -4, -2. And this, too, is a sideways parabola. And I'm not telling you that this method is better than the previous method. It's only that it is another option that we have for graphing. So the main thing here with graphing is sometimes it's just time consuming and you have to spend some time getting some points and then looking for a pattern in the graph.